Welcome to Altair SimLab, the simulation environment of the HyperWorks package thought to reduce the time needed for the FE modeling of volume assemblies. Altair SimLab is much more than a simple mesher or preprocessor. It supports you in all phases of your simulation process, from CAD to mesh, to solver setup and execution, to the post-processing. SimLab is a multi-solver environment. It includes Altair OptiStruct as its own solver, but you will be able to integrate any other solver in use in your company without changing the modeling process. As a strongly automation-oriented tool, SimLab allows you to easily script single operation or even whole processes simply through process recording without requiring programming knowledge. The first big difference between SimLab and the traditional preprocessors is that SimLab doesn't make any conversion of the CAD geometry while importing. SimLab actually just creates a graphic representation of the CAD geometry, but the information about the shape of the faces remains saved in the original CAD file. It's like to say that SimLab just reads a CAD database without actually importing it into a new format. This avoids any possibility of corrupting a CAD geometry while converting it. SimLab can import exchange CAD formats such as Parasolid or Step using its own internal reader. This is the way chosen by most users. In case of native CAD formats like CATIA, Creo or UG, SimLab offers the possibility to use the best possible reader you could have, the CAD software itself. For example, while importing a native Creo database, SimLab will invoke shortly the Creo installation in the background, using Creo itself as a reader. This direct access function allows the full access to all CAD options, including design parameters, so that you will be able to modify the design parameters and regenerate the geometry directly in SimLab. The SimLab approach of reading the original CAD geometry instead of converting it has many advantages, but does not allow to work on the CAD like you would do in a traditional preprocessor. We will see that, in fact, SimLab gives us the possibility to modify the shape of meshed bodies as if they were CAD, reducing the time spent for modeling. The next big advantage of SimLab is that you will not need any more to clean up or defeature the CAD geometry before you mesh it. This is particularly important for components like housings or engine blocks, and in general for all casted and molded parts with a big amount of edges and small features to be cleaned up. In SimLab, you will only need to set the average and the minimum element size you want to be reached. The meshing algorithm will automatically suppress or skip all the tiny features accordingly. A second meshing parameter defines the mesh density allowed on curved faces and fillets to better approximate their curvature. This allows to control easily the final size of your FE model. You can obtain satisfying results already by performing a quick mesh which requires only these simple parameters. In this case, SimLab could easily suppress hundreds of small edges and faces to mesh the geometry of this differential housing in only a few seconds. Fillets and holes have been accurately approximated without a big increase of the total number of elements. In SimLab, FE elements are not mapped on the CAD like in other preprocessors. An element does not really belong to any CAD face. It's more like the other way around. The CAD features are mapped on the elements. The FEM entities are grouped into topology entities, basically faces and edges, corresponding to the faces and edges of the CAD. So it is possible to retrieve all information and metadata from the CAD directly on the mesh. FEM faces have their own ID and can be identified as features exactly like if they were CAD faces. For example, cylindrical mesh faces can be recognized by radius or by orientation. As we will see, this approach allows to perform all operation of shape modification directly on the mesh, handling the FE entities exactly like if they were CAD. Of course, a one-click mesh is mostly not enough, since engineers have usually specific requirements and want to define locally the density and the structure of the mesh. In the upcoming video, we'll show you how this can be obtained through mesh controls or through the editing of the mesh itself.